To determine the non-permissible values for each of these expressions, we do need to have the denominator in its fully factored form first. With a, the denominator is already in its fully factored form. Our non-permissible value for a is 0. Now, 2 will go into 12 6 times, and x will go into x squared 1 time. So when I simplify it, I've got 6x is my simplest form, where x cannot equal 0. Looking at b, b already has the denominator, again, is in fully factored form. And to state my non-permissible values, I've got a cannot be -7 and a cannot be -1. Now that I've stated my non-permissible values, I can simplify by dividing out common factors, and in this case, the a plus 1 is a common factor. So my simplified expression for b is a minus 6 over a plus 7, where a cannot equal -7 or -1. Looking at c, again, our denominator is already in its fully factored form. Our non-permissible value is 0. We do want to factor our numerator of c so that we can see whether or not there's a common factor. To factor the numerator, common factor in both those terms is 2. So I'm going to factor the 2 out, which has me with 4y plus 1 over 8y. 2 will go into 8 4 times. So simplified, it'd be 4y plus 1 over 4y, where y cannot equal 0. With d, our denominator is not yet in full factored form, so we do need to factor that out first. I got x plus 7 is on my numerator, and 49 and x squared are both perfect squares, and because I got a negative there, that means I can do my difference of squares. That will be 7 minus x and 7 plus x. Now that I have it in full factored form, I can state my non-permissible values as being either plus or -7. 7 plus x, x plus 7, they're the same thing, so they cancel each other out, which leaves me with 1 over 7 minus x, and x cannot equal plus or minus 7. With e, same thing. We do not have it in factored form yet, so I'm going to factor both the numerator and the denominator at the same time. So numerator first. I know I've got a p as a common factor, and I also know that 4 goes into as a factor of both 12 and 8. So I'm going to pull out a 4p, which leaves me with a 3p minus 2. Now with the numerator, I can see that a p squared is a common factor in both, and I also know that 2 can go into both terms in the denominator. So that leaves me with a 3p minus 2. Before I simplify anything, I do want to state my non-permissible values, and in this case my non-permissible value is 0 and 2/3. Now I can simplify. 3p minus 2 cancels each other's out. 2 goes into 4 2 times, and the p's will cancel 1 out. So that leaves me with 2 over p, where p cannot equal 0 or 2/3. With f, our denominator is already fully factored out, which means I can state my non-permissible values right away. So I'm going to state those. So non-permissible value is -3 and 5. Now I need to fully factor out my numerator. Common factor in both terms in the numerator is 3, and that gives me 3 times t squared minus 25 in brackets. And that, of course, is over t plus 3, t minus 5. Now both t squared and 25 are perfect squares, and they are separated by a minus, which means I can use a perfect of squares on these guys. So I'm going to fully factor it further. Now, square root of t squared is t. Square root of 25 is 5, so t plus 5 times t minus 5. And that gives me t plus 3 on the bottom and t minus 5. And now I can simplify, and my t minus 5 terms cancel each other out, which leaves us with 3 times t plus 5 over t plus 3, where t cannot equal negative 3 or 5.